Each year, Americans consume over 20 billion hot dogs, enough to wrap around the earth more than 80 times if laid end to end. But how do factories in the US, Germany, or Japan manage to produce such staggering numbers, transforming fresh cuts of meat into billions of glossy, aromatic sausages? Behind every sausage lies a journey of industrial precision. From transportation, emulsifying, casing, smoking, cooling, to automated packaging, all orchestrated in perfect synchrony, like a finely tuned mechanical system, before finally landing on your plate. And today, we invite you to step inside some of the world's most advanced factories, to discover how humans turn fresh meat into a true masterpiece of food engineering: the sausage. Once banned in ancient Rome for being considered sacrificial meat, sausages have now become one of the most iconic foods in the world. It's estimated that over 100 million sausages are produced globally each day, fueling a massive food industry worth more than $50 billion annually. The modern story of the sausage began in 1939, when Oscar Mayer, USA, introduced the first vacuum-packed, sterilized sausage, a type that could last for weeks without refrigeration. 2 decades later, in 1961, sausages even made their way into space, accompanying Yuri Gagarin and later the Apollo 11 astronauts. From being banned on Earth to becoming the first food in space, the sausage has come a long way. Today, sausages come in many varieties, from beef, chicken, lamb, and seafood to fully vegan versions. But pork sausages still dominate the market, thanks to their rich flavor, emulsifying ease, and deep roots in European culinary tradition. In Germany, the homeland over 1,500 types of sausages, they are seen as the second soul of the nation. In fact, Berlin is home to the Currywurst Museum, dedicated entirely to this beloved dish. And now, let's step inside some of the most advanced factories in the world, where pigs are processed daily to create the delicious sausages we all enjoy. Across the globe, every day, millions of pigs are transported from farms to modern processing plants, the starting point of the journey to create delicious sausages. The pigs are transported in specialized multi-tiered trucks made of stainless steel, equipped with dozens of ventilation slits along the body to ensure continuous airflow. Inside, the floors are covered with thick sawdust to absorb moisture, prevent slipping, and provide warmth throughout the journey. Operators typically inspect each compartment manually to ensure the pigs are traveling safely and are not overcrowded. Each truck can carry between 80 and 200 pigs, depending on their weight and the design of the compartments. An automatic ventilation system maintains a stable temperature of 18-22 degrees Celsius, helping to reduce stress for the animals during trips that can last several hours. The multi-tiered structure not only optimizes space, but also facilitates fast and safe loading and unloading, minimizing injuries to the pigs before they reach the processing plant. Notably, in Europe, transport routes exceeding 8 hours are required to include rest stops, where the trucks are cooled and pigs are automatically supplied with water. After a long journey, the pigs arrive at the processing plant. At the receiving area, herds of pigs are unloaded from the specialized trucks and guided into holding pens for inspection. Each pig is weighed, scanned for traceability, and given a general health check to remove any individuals showing signs of illness or stress. In large facilities in Europe or the US, AI cameras and infrared sensors monitor breathing, body temperature, and behavior, reducing the need for manual intervention. Here, pigs are allowed to rest for 8 to 12 hours in a well-ventilated space with non-slip flooring and soft lighting, as their calm state is essential for ensuring optimal meat quality later on. Once the pigs have rested sufficiently and passed inspection, the stunning and initial processing procedures begin. In large processing plants across Europe and North America, CO2 gas stunning is the most commonly used method. The pigs are moved into a sealed chamber via an automated conveyor system, where a controlled mixture of 70 to 90% pure CO2 gas is evenly introduced. After about 20 to 30 seconds, they fall into a state of deep unconsciousness, unable to feel pain or fear. After stunning and preliminary processing, the pig carcasses are moved to the cleaning and surface decontamination stage. On the conveyor line, the bodies are immersed in a hot water tank at 60 to 65 degrees Celsius for about 3 minutes, a temperature just high enough to soften hair roots without cooking the skin. Immediately afterward, the pigs pass through a rotating deherring machine where hundreds of rubber rollers gently rub the surface, removing almost all hair within seconds. After leaving the deherring machine, the carcasses are hung upside down on a chain conveyor system and taken to the singeing area for sterilization. Here, workers use gas torches or propane burners to quickly flame the skin surface, burning off any remaining fine hairs and eliminating microbes, while also creating a clean, dry, pinkish skin appearance. The carcasses are then given a final wash and disinfection using warm water or steam at 55 to 60 degrees Celsius to completely remove any remaining bacteria before proceeding to the evisceration stage. After the pig carcasses have been cleaned and disinfected, the process moves to the abdominal incision and organ removal stage. The pigs, suspended upside down, travel along the conveyor line, where workers use specialized surgical knives and mechanical guiding systems to make a precise incision along the abdominal axis. The internal organs are removed manually with mechanical assistance, ensuring the intestines are not ruptured and the meat remains uncontaminated. The heart, liver, lungs, and other organs are collected intact for veterinary inspection and sorting, while the main carcass is sent through an automatic splitting machine. Here, a bandsaw cuts along the spine, dividing the body into 2 symmetrical halves. Laser sensors ensure absolute precision, while cold water jets operate simultaneously to reduce friction and prevent cross-contamination. Once splitting is complete, the carcasses are transferred directly to the forced chilling area, where the temperature gradually drops from 38 degrees Celsius to 4 degrees Celsius over 16 to 24 hours. A continuous flow of cold air ensures even evaporation of surface moisture, minimizing water loss and forming a natural protective layer on the meat. Once the carcasses have been chilled to 0 to 4 degrees Celsius, the process moves into the deboning and sorting stage. On the conveyor line, the chilled half carcasses enter the automated deboning area. Here, a robotic system controlled via a central touchscreen panel begins the precise separation and bone removal process, accurate to the millimeter. Mechanical arms equipped with high-speed rotary blades and optical positioning sensors analyze the structure of each carcass, bone, muscle, and fat, to adjust cutting force accordingly. The meat passes through multiple sequential cutting stations, where disc saws and positioning clamps work in sync to separate the shoulder, loin, ham, and ribs. All operational data is displayed on a PLC control screen, allowing technicians to monitor and make real-time adjustments. In large European plants, such a line can handle 5 to 10 tons of meat per hour, with virtually zero margin of error. After deboning, the meat is sorted based on its intended use, a critical step to optimize the entire production chain. On the conveyor, AI cameras and color sensors detect brightness, pH levels, and fat ratios, then automatically sort the meat into different product streams. Shoulder and ham cuts with balanced lean-to-fat ratios are sent to sausage and ground meat production. Loins, pork belly, and baby back ribs are selected for fresh packaging or smoking, while pure fat portions are used for pâté, cooking oil, or industrial ingredients. And now the journey enters the stage you've likely been waiting for the most, where fresh cuts of meat are transformed into sausages, the iconic culinary staple found in millions of meals around the world. Have you ever wondered what gives sausages their smooth, springy texture and distinctive flavor? The secret lies in the fine cutting and emulsifying stage, the heart of the entire processing line. Before entering the emulsification phase, large meat blocks are sliced by industrial cutters into evenly sized pieces about 2 to 3 centimeters thick. This ensures uniform grinding and minimizes heat generated by friction. From there, the meat is fed into industrial grinders, where stainless steel blades rotate at speeds of 1,500 to 3,000 RPM, breaking down each muscle fiber until the mixture reaches a smooth, consistent texture. This system can process up to 2 tons of raw material per hour, setting the stage for the blending and emulsifying step, a foundational process that determines the elasticity, binding, and ideal color of the sausages you see on supermarket shelves. Once the meat mixture reaches the perfect smooth and elastic consistency, the seasoning stage begins, the point where the sausage's flavor profile takes shape. In modern factories, high-capacity vacuum mixers gently churn the mixture at speeds of 20 to 60 RPM, allowing the spices to distribute evenly without raising the temperature. The seasoning blend typically includes salt, pepper, onion powder, garlic powder, and nitrite, a compound that preserves the meat's natural pink color and inhibits bacterial growth. Some German or American sausages may also include sugar, milk powder, or soy protein powder to enhance binding and texture. Around the world, sausages come in hundreds of unique flavor profiles, from Germany's mildly spiced bratwurst with white pepper and nutmeg to Spain's fiery chorizo packed with paprika and garlic. Each flavor is a cultural snapshot where culinary identity meets precise technique. So which sausage flavor do you like best? Once the meat mixture has reached the ideal elasticity and uniformity, it is transferred to an industrial vacuum filling machine. Here, the hopper system removes all air from the mixture to ensure a smooth, air-free texture during shaping. Under constant pressure, the emulsion is evenly pumped through a tube to the stuffing nozzle, where casings are preloaded by operators. The sausage casings can be natural, typically made from pig or sheep intestines, offering elasticity and a traditional flavor, or collagen casings, which are made from animal protein and valued for their thinness, strength, and heat resistance. The machine injects the filling into the casing at high speed, producing a continuous sausage strand. Immediately afterward, a dual-axis twisting mechanism segments it into evenly sized links, tightly twisted at each junction to shape individual sausages. Workers swiftly hang these freshly formed sausage chains on stainless steel racks in preparation for the steaming and drying stages. Have you ever wondered why sausages are always cylindrical and not square or flat? In fact, it's the result of centuries of culinary and technical refinement. The cylindrical shape allows for even stuffing pressure, preventing casing tears, and ensures efficient, uniform heat transfer during cooking or smoking. It's also easy to slice, package, and store, ideal for modern automated production lines, and above all, it fits the hand, bites cleanly, and gives that signature snap, making sausages a true icon of modern cuisine. Sausages can be cooked using 2 main methods, steaming or smoking, depending on the desired product type and flavor profile. For steamed sausages, they are placed into massive industrial steam ovens, where hot steam at 75 to 85 degrees C envelops them for 30 to 60 minutes. This ensures even cooking, a moist and tender texture, and excellent juice retention inside. For smoked sausages, the process takes place in sealed smoke chambers, where sausages are hung on stainless steel or wooden racks. Natural oak wood smoke or sawdust circulates at 50 to 75 degrees Celsius, giving the sausages their signature golden hue and distinctive smoky aroma. After cooling, sausages enter the inspection and packaging phase, the final, yet arguably most rigorous stage of the entire production line. Before packaging, each sausage is examined by optical scanners and AI sensors for color, shape, doneness, and surface integrity. Any sausages found cracked, misshapen, or unevenly cooked are automatically removed from the conveyor. Next, metal detectors and precision scales ensure absolute food safety, detecting metal contaminants as small as 0.5 millimeters and verifying the exact weight of each package, with a margin of error no greater than 0.1 grams. Only after passing all these checks are the sausages sent to vacuum or modified atmosphere packaging MAP machines, where a mixture of nitrogen and CO2 replaces the air, extending shelf life to 30 to 60 days. From there, the finished packages are boxed and transported in refrigerated trucks to supermarkets, restaurants, and kitchens across the globe. ready to appear on dining tables or in familiar breakfasts each day. And now you know, that sausage you enjoyed this morning has undergone an astonishingly meticulous and precise journey to reach your plate.